Today I'm going to show you guys numbers 1, 2, and 3 on the 13-6 classwork. Let's go ahead and start by reading some directions. Solve the cube root equations. Check your answer by evaluating using your graphing calculator. Number 1, we have 4 plus x minus 1 to the 1/3 equals 2. So if I want to solve this, recall that we have these steps on the top of the page. Just put them here for easier viewing. Step 1, isolate the radical term. So what is the radical term here? We want to remember from the very top of the page that if I have the nth root of x, that is the same thing as x to the 1 over n. So if I have the cube root of x, that is the same as x to the 1/3. So if I see a 1/3 power, I want to recognize that is the same thing as a root. So if I look at number 1, I see that happening here. I want to isolate that. And in order to do that, we're going to subtract 4 on both sides. We now have x minus 1 to the 1/3 equals -2. Next, it says step 2 to cube both sides of the equation. So since this is a 1/3 power, we're going to go ahead and cube both sides. So both sides are to the 3rd power, and that is going to undo this so that we only have x minus 1 here. And on the right, that'll give us -8. Almost there. We're going to add 1 on both sides to continue solving for that unknown. And x is equal to -7. We're going to do the same thing for the second problem. Isolate the radical term. This one is the radical term, so we are going to divide both sides by 7, leaving us with the cube root of 2x plus 5 equals 3. Cube both sides. So we have 2x plus 5 is equal to 27. Solve for the unknown. Subtract 5 on both sides. Divide both sides by 2. And x is 11. Now let's go ahead and also solve 3 so that we can see what those steps look like. So step 1 again is to isolate the radical term. From what we see here, the radical term is already alone. So we can go ahead and skip to step 2 and just cube both sides so that the radical gets undone. And we have x minus 1 is equal to 125. Then all we have to do is add 1 on both sides to isolate our x value, and we get 126. So if we go back and read the directions from the other side of the page, it did say to also check our answers with the graphing calculator. So let's kind of briefly talk about how we would do that. If I look at my equation, there is a left side and a right side. I can think of it as breaking up the left side into one equation and the right side into the other. So for the left side, which is cube root of x minus 1, I'm going to go ahead and pretend it's its own separate equation. And on the right side, we have 5. So I'm going to say y equals 5 is a separate equation. And if we go to our graphing calculator and we graph it, depending on your window, it might look slightly different. Well, I know what y equals 5 looks like. Y equals 5 is going to be some kind of horizontal line that goes through 5 on the y-axis. And then if I graph y equals cube root of x minus 1, that's a cube root function that's maybe shifted to the right one. So if it's a little bit skewed, or if we scale accordingly, I should get a graph that looks something along the lines of this. And I should see that both graphs intersect at this one point. Once I've adjusted my window so that I can see that intersection point, I should be able to find that intersection using that feature on my calculator. You can also graph it on Desmos, but if you do this on your calculator, it will give you that x equals a number and y is equal to some number. For the sake of this problem, we only really care about x. And if you get 126 when you check that intersection point, or 126 comma something when you find that point on Desmos, if these numbers match, then you're on the right track. If not, then you need to go back and check your work.